Hello friends, welcome back to my YouTube channel Physics Club by Shakti sir. So in today's video we will discuss about few more numericals about collision. So let's discuss our first question. It says that two 22.7 kg ice sleds are placed a short distance apart. As you can see here, we have one sledge here and front sledge here. One directly behind the other as shown. A 3.63 kg cat standing on one sledge jumps across to the other and immediately back to the first. What it means? It means initially the cat was here and jump in this way and come back immediately to the first one. Okay, are made at a speed of 3.05 meter per second relative to this is the speed of the jump of cat. Find the final speeds of the two sleds. So let's see the scenario how we will proceed in this numerical. So when the cat jump from this sled, the first sled, when it move in this way towards right, then the sled will move towards left. So both will have the speed. The sled is moving toward left, the cat is moving towards right. So we will conserve, because initially when the cat was here, so initially the system is at rest, right? So the momentum before the jump is 0, but momentum after the jump is conserved. Cat is moving toward right, sledge is moving toward left. So according to the conservation of momentum, what we can write here? So we can write, let's say first jump. So according to first jump, this is the mass of the cat, then speed of the cat, which must be equals to the mass of the sledge and speed of the sledge. Sledge is moving towards left, right? After the jump, let's put the values. Mass of the cat is given, it is 3.63 kg, and velocity of the cat is also given, which is 3.05, divided by mass of the sledge, which is 22.7 kg. So in this way we will calculate the value of v1, that is the speed of the sledge toward left after the jump. So this is the value. After your calculation you can get the value 0.487 meter per second is the speed of sledge toward left. So this is speed of sledge towards left. Okay, now we will discuss second jump. So second jump takes place like here. So cat is initially it is at rest, cat is moving toward right and then immediately come back. So before the collision only cat is moving with some momentum, so we will conserve the momentum again. So listen carefully, before the collision with the second sledge only cat is moving, so the momentum of the cat will be mc and vc. This is the momentum of the cat, and after the jump what will happen? When the cat move here and come back, the sledge will start moving towards right, but the cat is moving toward left after the jump, right? So one is positive and this is negative. Sledge is moving toward positive direction, right direction, so m2, that is the mass of the sledge, speed of the sledge, negative, mass of the cat and speed of the cat. Why negative sign? Because after the jump cat is moving towards left again towards the first sledge. So let's put some values. So you will put here, you can see here, you will get 2mc vc equals to m2 v2, right? Let's plug the values. What's the value of mass of cat? So mass of cat is equal to 3.63 and speed of cat is again 3.05, divided by mass of the sledge is 22.7. This is our v2. So after calculations you can get v2 is equal to 0.975 meter per second. This is the speed of sledge toward right. Okay, this is v2, and this is our v1, right? Now let's move, because we need to calculate the final speeds of the two sleds. So this is one of the answer. This is the speed. This is not the answer, right? Because the cat is coming back to the first one. When the cat is coming back to the first one, then what will happen? It is already moving in this direction, right? And cat is coming back. So before the collision, cat is coming toward left, sledge is moving toward left before the collision. And finally the cat will come into the sledge here. Then both will move together with the common velocity vc. Both will move together towards left. So look carefully. Before, this is first incident is when cat was here and it jumped here. Second incident, it come back. And third incident, finally cat in the first sledge here. So when the cat is here, finally both are moving towards left with some common velocity. So you can say moving left. Now the situation is moving left. So finally before the collision of the cat with the sledge 1, before the collision, what you can write? So mass of cat, speed of cat, plus mass of sledge, speed of sledge. This is the before, and when the cat is inside the sledge, then they will move together. So we can write mass of cat plus mass of sledge with common velocity. Let's say it is v dash. Common velocity is v dash. Okay. Let's substitute the values. Mass of cat is equal to 3.63 and speed of cat is 3.05 plus again m1, that is the mass of sledge, which is 22.7, multiply v1. So we have calculated the value of v1 here. You can see it is 0.487, right? This one is equals to mass of cat. What is the value of mass of cat? It is 3.63 plus m1, that is the mass of the sledge, 22.7, and v dash. So it's a simple calculation. Once you do the calculation, you will get the answer of v dash. So finally v dash is equal to 0.840 meter per second. So this is the speed of the sledge 1, and this is the speed of sledge 2, and this is the speed of sledge 1, this one. Okay, this is your answers, right? So it is an interesting question, but you need to know how to solve this type of question. Let's move. Okay, question number 2. So we have our question number 2. It's a simple, straightforward question, but still you need practice to solve this type of questions. So we have a slide. Initially, we have a block A, which is here at rest at a distance at a height of 2.5 meter. So it has a potential energy, no kinetic energy. Then there is no friction. It is smooth surface. So it slide down, collide with block B here. So after collision, you have two situations: if the collision is elastic and if the collision is completely inelastic. So we will discuss first one. If the collision is elastic, then what will happen? This will move forward, and due to friction, due to the presence of friction, after covering some distance, the block will come to at rest, right? So we need to calculate the distance d, after how much distance the block comes to at rest, okay, under elastic collision. So we know the formula how to calculate the elastic collision velocities, but before that we need to calculate the speed of A here, A. So initially it has potential energy, all the potential energy converted into the kinetic energy at the ground surface. So this is our first step. So we can say all the potential energy is equals to kinetic energy for A, block A, right? So potential energy is equal to mgh, which can be equals to 1/2 m VA square. Mass term cancels. What you will get? 2gh, like this, Va. This is your Va. That is the speed of block A at the ground. Speed of block A at the ground. All right. Now we will calculate what is the velocity of block B after the collision, because we just calculated the speed of block A. Now there is a collision, elastic collision. Due to the collision, it will gain some velocity. So what is the velocity it will gain? So I am writing that velocity is equal to Vb. So we can easily calculate the value of Vb, that is Vb is equals to, we will use the formula, we know the formula, m2 minus m1 divided by m2 plus m1, then u2 vector sign plus 2 time of m1 divided by m1 plus m2, m1 plus m2, and here u1. So what is our u1? u1 is the velocity which we have here, but we just calculated the velocity which we have here, that is velocity of A. So we will write here velocity of A. This is the velocity, positive. Okay, one more thing is, initially the block B is at rest, so that is this value is at rest, so we will put 0. So once you put u2 equals to 0, this whole term will become 0. So velocity of V is equals to 0 plus 2 times of m1 divided by m1 plus m2. And what is the value of m2? You can see here m2 is equal to 2 times of ma. So 2 means this is 2, this is 1. Okay. So it is 2 times of m1, and ua we just calculated square root of 2gh. So velocity of B is equal to 2 by 3 m1 divided by m1 square root of 2gh. m1 cancel. So it is Vb is equal to 2 by 3 square root of 2gh. All right. So this is one of the term we need to solve this question. Now we have calculated the speed of B with which it will start moving. So it means it will gain the kinetic energy, but after covering some distance d, finally it stops. So its final kinetic energy will be 0. So we can write here the final kinetic energy will be 0 here. Final kinetic energy is equals to 0. So use the work energy theorem. So according to work energy theorem, that is change in kinetic energy is equals to the work done by all the forces, but here the only force acting on the block is the frictional force along the horizontal direction. Okay, so final kinetic energy is 0, but the initial kinetic energy is equal to 1 by 2 m2, that is mass of block B, and speed of block B square, this one, is equals to work done by friction is what? Negative frictional force and the distance. Let's solve this. So it is negative 1 by 2 m2. You can get the value of m2. Okay, so m2 as it is v2, this one, 2 by 3 square root of 2gh. So when you square, you will get 4 by 9 multiply 2gh is equals to negative friction. So what is the value of friction? So friction is nothing but, you know, friction is equal to mu n, and here n is equal to mbg or m2g. So you will put mu m2g and d. So m2 term and m2 term will cancel, g term and g term will also cancel, 2 2 cancel, negative and negative cancel. Okay, so finally we are left with 4 by 9 h is equals to mu d. Okay, 4 by 9 h by mu is equals to d. So 4 by 9 h is, it is given in the question, h is equal to 2.5, and mu is also given, mu is equal to 0.5. 0.5 equals to d. By solving all this stuff, what you will get? You will get d is equal to you will get d is equal to 2.22 meter. Okay, this is what you will get. All right, this is our part A. Then part B, find d if the collision is completely inelastic. Okay, so if the collision is completely inelastic, B part. If the collision is completely inelastic, then according to the conservation of momentum, we can write m1 va, that is before the collision, is equals to m1 plus m2, because completely inelastic means they will stick with each other and move with some common velocity. By putting the values, so this is m1 va divided by 3 times of m1 equals to vc. Okay, m cancel, m1 cancel. What you will get? You will get vc is equal to va by 3. We have calculated the value of va. This is the speed va, square root of 2gh. Now again we will use the work energy theorem. So according to work energy theorem, we can write change in kinetic energy is equal to work done by friction. So again, final kinetic energy minus initial kinetic energy, that is, now both the blocks are combined, so that's why we will use this one, initial kinetic energy with common velocity, and negative mu m1 plus m2 g d, this one. Now mass term cancel, negative and negative cancel. We will substitute the value of vc, so it is 1 by 2. What is the value of vc? Here, this is the value of vc, that is va by 3 with square sign is equals to mu g and d. Okay, now half, it will become 9, and va, what is the value of va? You can see here va is equal to square root of 2gh. So va square is equal to 2gh. So you will write 2gh, all right, equals to mu g d. Again you will see that the g term and g term will cancel, 2 and 2 will cancel. So finally we have h by 9 mu equals to d. Put the value, so it is h is equal to 2.5 divided by 9 multiply mu is equal to 0.5 equals to d. So in this case you will get the value of d is equal to 0.556 meter. So it is much lesser as compared to the first case. So this is our answer for part 1, and this is our answer for part B. Okay, so this is the question you need to understand. Try to understand this question, how we solved it. Okay, let's move toward question number 3. So question number 3 says, we have a 35-ton railroad freight car. This is the freight car collided with a stationary engine. So this is our stationary engine. They coupled together, that is they are moving together after the collision, and 27% of the initial kinetic energy is dissipated as heat, sound, vibrations and so on. So this is the initial kinetic energy because it is moving with some speed. So 27% of the initial kinetic energy is dissipated. What is left? With that kinetic energy, this system is moving. So find the mass of the engine. So we need to calculate the mass of this engine. So let's try to solve. So firstly, there is a collision between these two, right? So we will conserve the momentum. Solution. So conservation of momentum says mass of the train, right, or you can say mass of the rail and speed of the rail is equals to, after the collision, what you have, because after the collision they both are moving with the same, so mass of the rail plus mass of the engine, they are moving together with some common velocity vc. This is the situation. Okay, we are given mass of the, so its mass of the rail equals to 35 ton. All right, now our second equation, we can make our second equation. Our second equation says about the kinetic energy. What it says? It says 27%. It means the final kinetic energy will be whatever the initial kinetic energy negative 27% of initial kinetic energy, like this, because 27% of the initial kinetic energy is dissipated, so we are subtracting that initial kinetic energy. So it is k initial negative 27 divided by 100 times k initial. So you will solve this, you will get 0.73 k initial is equals to k final. Okay, final kinetic energy can be written as in terms of like this. Final situation is equal to 1 by 2 combined mass of the rail plus mass of the engine and the common speed, and the initial kinetic energy 0.73 times half mass of the rail and v1 square, or velocity of rail square. This is the situation. All right, so we will use our equation number first and our equation number second to calculate the situations. Now let's see what we can do here. We can put the value of vc from equation first here. So plug the value of vc from equation first into equation second. So plug vc from first into second. So you will get 1 by 2 mass of rail plus mass of engine, then vc square. Vc square is equal to mass of rail vr, this will go with square signs, and mr plus me square. This is what you will get when you have vc square is equals to 0.73 times half mass of rail and speed of rail square. Okay, so let's cancel the terms. You can cancel this term with this term. Mass of rail, one term will cancel, half and half can cancel, and this whole term with square, it will cancel. So what we left is mass of rail divided by mass of rail plus mass of engine, this one, is equals to 0.73 Yeah, 0.73. So let's solve this one. So it is mass of a rail equals to 0.73 mass of rail plus 0.73 mass of engine. So mass of rail minus 0.73 mass of rail equals to 0.73 mass of engine. So once you solve this situation, you will get 0.27 mass of rail equals to 0.73 mass of engine. So our target is to calculate the mass of engine. So it is 0.27 divided by 0.73 times mass of rail. So mass of rail is given 35 ton. So 35 ton is equal to mass of engine. So once you can solve this situation, you'll get the value of approximately 13 ton. So you will get 13 ton. 13 ton is the mass of the engine. So this is the beautiful question, just solved answer. So if you are interested for all these situations, if you like these questions, if you are understanding what I am saying, then please do subscribe my channel, and we will see you again in the next video. Wish you all the best. Bye bye.